Hello, this is Information Service Engineering and this is lecture number 6, putting it all together. In this part of the lecture we are going to talk about linked data programming, and let us start. So, the required components to have a linked data-driven web application are the following. First, we need the local RDF store, which is responsible for caching the results and permanently store acts as a permanent storage here. Then we of course need the logic, which is the controller, and a user interface, which is the business logic here. Those components, and especially the UI, the user interface, they don't have to be load specific, so linked open data specific user interfaces. Then we need the data integration component here, which is responsible to gather the data, so it can get data directly from the linked open data cloud, as you see, or via some semantic indexer. And then we have the data republishing component, which is responsible to write back application-dependent data into the web of data. And those are all the components which are necessary in order to build a linked data-driven web application. So the easiest way to start and make an application is to use a suitable library. And here are some of the libraries you can use for linked data programming, and depends on the programming language you are using. So we are providing here some links for PHP, C#, Java, and Python. So for this lecture we are going to use the last one, the Python one, but all the rest, they work equally well. We are going to use it only for simplicity reasons. So we have first to start by installing our Sparkle wrapper in Python here, and then we need to access the linked data via some Sparkle endpoints. And for this part, the part of this lecture, we are going to choose DBpedia, just again for simplicity reasons. So let's now think of an example. What do we want to do here today is to build a simple application that looks for today's birthdays of famous people, such as, for example, scientists. So what do we want to do? We want to create a list of scientists whose birthday is today, including some additional information about them, meaning the year of birth, some short description, or some picture if the picture is available there in our data source. So let's create a simple web page in the end for this task, which will be responsible to display in a browser the results that we have. For that task we are going to use Python and the Sparkle wrapper library. So before starting we have actually to analyze our data. And the first step in analyzing data is usually a manual task. So we go in the page in DBpedia of a famous scientist, let's pick Albert Einstein, and we have to go check what is in there and what we can use before starting coding something. So we will visit the page and check what is there, if there is a description, how is the property called for the description, and everything. After the manual now evaluation, we want to analyze via Sparkle and get the data via Sparkle. So what do we want first? We want to determine what kind of entities are we looking for. And we said that we are looking for scientists, so we say question mark scientists should be of RDF type scientist. Then, what other information do we need? So we said that we need to know the birth date of the scientist. We need to have the label and not only the URL, the URI. So the label as well of the scientist, which is the actual name. We need to have a description because there might be scientists that we don't know, so it would be nice to have a description there that presents them. And then we need to have a picture, but this picture might not always be there, so this we make it optional. So that means that if there is a picture there, yes, get it and bring it so that we use it in our application, otherwise it's fine, we can continue without it. And then we have to apply the filter criteria. So what are the filter criteria we want to apply here? So first is the language, so they want them we want the names to be in English because we want to build, let's say, an application in English, and also the description to be in English as well, so that we can all understand it. And then we have some filter criteria about the date, because we actually said that we want to present scientists that they were born today. So first, you see that we are going to use this substring and string, so we are going to transform the birth date into a string. It's not originally a string. And then with the substring, we are going to get whatever is in there from the 6th position and later, because the dates in DBpedia, they start first with the year, and then it comes the month, and then the date. So we don't care about the year, but we care about the month and the day. And this is if we want to do it manually, so if every day we want to go and ask the same query in DBpedia, so we manually change the date there. But if we want to do it in a more automatic way, let's say we can, because there is this BIF card date, which is a Virtuoso TripleStore built-in function to get the current date. So we can just use it in order to every time to have the current date and not make it as a manual task. So our query, we are going to ask it in DBpedia, so let's go there together and check. So this will be our query with all the filter criteria as we discussed up to now. So we go, execute our query, and this is the result we get. So in the first column, you see we have here the birth date is the birthday of today. So apparently today is 4th of April. Then in the second column, we have the thumbnail, when is there. You see that in some cases it is missing. In the third column, we have the scientist URI, then it comes the name, and in the end, it comes here the description about those scientists. Great. So we have our data. And let's go back now. So what do we do? Next step. We said we are going to use Python libraries here, so you should have installed Python in your computer. You can find everything here in the link, and the Sparkle wrapper for Python. If you follow those links, you will find also the instructions for installation. And if you do that, we provide the code, which you can find in the link here down in the corner of this slide. And this is how the code will look like in a TextPad here in your computer. But actually, for simplicity reasons, we created also a collaborative Python notebook through Google. So you need to have a Google account to use that one. And here we can actually run it online. So here is how it looks. I first press and then explain to you. First, we have to install this Sparkle wrapper because it's not pre-installed. This might take some seconds. And then we are going to install here some of the other packages. We need the URL package because we are going to deal with URLs, the date time, because again, from the Sparkle wrapper, we want to import the Sparkle wrapper, the JSON, XML, N3, and RDF. I don't know if we are going to use all of them, but we can import them. And now our next step is that we want to define that DBpedia is our Sparkle endpoint, and this is how we do it. We define DBpedia as our endpoint. Great. And then next comes the query. So this is the same query we addressed in DBpedia before, but now we will do it through Python here. So it's the same query. Careful that we have 3 double quotation marks here in the beginning and in the end. So that is to avoid every masks for the backslashes and everything here. So this is our query. And then in the end here is the format that we want to have the output. So we determine here that we want the return format to be in JSON. And that line here it's to execute the query. So I run it and the query is executed, and the result of the query is here in the results. So we said that we want to build a web application, so we have to print some HTML page. So this is how we are going to create our HTML output. You have to put here this HTML code. In the beginning, we are going to put here the scientific birthdays of today in the headline. And here in this line, we determine in the format that we want to have the date in. So first comes the month, the year, the month, and the date here. And then we printed scientific's birthday of today, the format that we have here in the date. And then we know from Sparkle that we can have bindings for the variables there, and this is what we are searching for here. So first we are searching for scientists. So if we find results there in the scientists, we are going to keep them here in the wiki URL. But because we don't want to link our application to DPpedia directly, but it's better to link it to Wikipedia, we just replace the first part of the string of this string of DPpedia string with the Wikipedia page of that specific scientist, and then we are going to link it, and then we append the name or the name of the scientist, and then we are going to link it to the Wikipedia page. Otherwise, we just put none here. Then we continue with the name of the scientist, which we extract here from the name. If it's empty, again none. Then we continue with the birth date. Then we continue with the description. And in the end, we have the thumbnail. So if we find the thumbnail, we put it here in this pic variable. Otherwise, if there is no thumbnail, we put the standard picture here. And that is a picture with a question mark, so that we always have a picture there for uniformity reasons. Great, so we can execute that. And this is how it looks like, our HTML code for the web application we wanna build today. And actually, we have this nice option here in the end. So here we repeat the same things, but whatever we do here for the HTML code, we write it in a file. So that's why we used here this F write everything in a file, and then we close the file, and we have the option to download the file, which is called birthday.html. So if I run this one, here I'm going to download this file and open it here for you. So this is how it looks like, our web application, where we print the birthdays of the scientists that they have birthday today. So you see that we have here a date, only the year actually, because the date we know it already is for today. You see that we don't have pictures for everyone. This is, for example, the question mark. Remember I told you for those that we don't have a picture, we put the question mark. Then it comes the link to Wikipedia, the short description, etc. These are all the people that they were born today. So, going back to our slides, yeah, that is a screenshot of the same application, but ran like a couple of days ago. I hope you enjoyed up to now. So, in the next part of the lecture, we are going to talk about knowledge mining and information extraction.